Hello, everybody. Nick Titiro here. It's time we start talking a little bit about data structures. And basically, data structures, if you're interested in it, we do have a HIT class here at Lakeland. We don't go into that deep into these courses, but it's how you arrange your data. And for this course, we arrange our data as in either an array or a list. Now, if you're in taking Python, Python does not have arrays. So in Python, we use list, and in other languages, we will use arrays. But fundamentally, what are they? They're not, first of all, it's not interchangeable, but they're fundamentally a collection of items or a collection of the same items that we can reference to them. Now, throughout the course of this video, I'm going to be using a lot of metaphors, but they're not really metaphors because this is how we would actually apply the concepts of a list or an array. So let me jump up to my screen here. And this is a Google Earth view of Lakeland Community College. And we can begin to use the metaphor, but more in reality, this is how we'd actually program. If you look around the campus, we have parking lots. All right, all over campus, we have parking lots. And if I zoom into any one of these parking lots real quickly, if you pay attention to things, and I encourage people to really start paying attention to things, this picture, this Google Earth picture, was probably taken early May. If you notice this big white thing here, that's our graduation tent, which usually goes up about a week before commencement, and then it comes down about a week after commencement. So that's early May. So kind of a little investigation there. But we have parking lots, and I'm going to zoom in on these parking lots. And you'll notice that the parking lots are pretty structured, right? We have cars in parking spaces. Some parking spaces are empty, but basically the structure of the parking lots are consistent. Now, if I scroll over this way, this is the faculty lot way over here. And you'll notice that we have some cars. I'll zoom in some more. I don't think my car is here. I'll zoom in some more. And you'll notice that we have cars parked in specific positions. Now, in an array, when we build an array, we tell it the specific number of spots available, right? And that takes a lot of planning. You'll see me do that in a little bit. But in array, it is pretty much a fixed spot. Doesn't really matter so much how many cars are in that spot, but it's more importantly that we have all these spots. So let's say hypothetically, this particular parking lot holds 100 parking spaces. That means that regardless of the number of cars, if I only have one car in there, the parking lot still holds only 100 spaces. And there's reasons that we use arrays versus a list. Now, let me go to another area. This is an aerial view of the Geauga County Fairgrounds. And you'll notice something. I mean, where's the parking spaces? First of all, if you've not been out to the Geauga County Fair, it's absolutely fabulous. It's really kind of a cool place to go. But where are the parking lots? They have these minor little parking lots over here. It looks more for employees. But if you go to the fair, you will notice that there's literally hundreds of cars parked in these green area. And if I zoom in on them, scroll around, you'll actually see where they're kind of the lanes are burned, but there's no specific spots. This is more of a tune to a list where we basically would be putting cars pretty much anywhere. Now, we would still be able to reference those cars in a specific order, but you'll notice that we don't have a fixed amount. So maybe on a busy day, they can fit in this particular area. Maybe on a busy day, they can fit 200 cars. Maybe on a normal day, it's 150 cars. So there's actually no spaces specifically assigned. So your question is, which is better? Is the array better or the list better? And it's really about what you're going to use. For a array, you have to plan this out, right? But because you plan it out internally to the computer, it's very efficient because the computer knows there's only going to be 100 potential cars in this given array. So the planning, the pre-planning takes a little bit more effort, but the implementation of actually using it is a little bit more efficient for the computer. So, but if we go back to my list analogy, you might say, well, this apparently is more easy to understand. Not really. See, if you go out to the fair, there's some overhead to this style of parking. There's usually like 5 to 10 people who work for the fair that are directing cars and telling people where to go. And then, when you're done with the fair and you come back, you might have to ask somebody specifically where something is. And it will often follow a last in approach where they're just putting more and more people there. So the overhead on this one is a little bit more to a computer. So the overhead on lists are a little bit more computer. If you're in programming logic and you're using Python, right? If you're using Python, Python doesn't use arrays. Native Python does not use array. Native Python use list. But in the demonstrations I'm going to do in a little bit, I will be concentrating on the specifics of either Java or for Python. All right. I'm going to do a whole series of different examples in array because I want to just go through a lot of examples in a short amount of time. I'm not going to use an IDE. I'm going to go back to our old friends, the J shell. So it gives me a chance to just, build examples, work with examples very, very quickly. And then later on in another video, I'll do demonstrations about actually the implementation of a given array. Now, let's use the initial example I did earlier about a parking lot. And we're going to say we want to build a parking lot of models of cars or makes of cars. We'll keep it simple. I don't know makes and models of cars, but the make of a car. All right. So this parking lot is going to hold potentially 100 cars. How I would do that is, first of all, I'm going to go into J shell. Give it a second and make it just a little bit bigger. All right. Since I'm looking at the make of the car, we got Ford, Chrysler, BMW, whatever, that's going to be a string. All right. So I'm going to say string and then my 2 brackets. That's going to tell that I'm initializing or I'm creating a string array. And I'm going to call this string array parking lot A, right? And it's basically going to be new. So I'm going to equal new, and it's going to be string, and we're going to put 100 spaces in that parking lot. Now you'll notice immediately it built that array, and it says it's basically empty. That's what the null, 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 null across the board is. There's basically 100 empty parking spaces or a bunch of or null parking spaces there. Here's the issue, very similar to a parking lot analogy or a metaphor. If I want to expand that parking lot to 125 parking spaces, there's no easy way to do it. What I would have to do is basically go and create a whole new parking lot, copy those spaces to the new parking lot where the new parking lot's 125 spaces. So planning the size of your array becomes very critical. You want to optimize how many do you really need. You don't want to say, well, I'm going to create a parking lot of 1,000 spaces. Potentially, no. There's a lot of planning involved. Now, how do we assign a car to a given position? Well, we use our friends, the indices. So let's say I want to put a Ford in the first space. So I would say parking lot A, indice 0, the first space, is going to be equal to a Ford. All right. Let's say I'm going to put a Toyota into the second spot, spot 1. I would say parking lot A, indice 1, is going to be a Toyota. Now let's take a look at our parking spaces here. So because I'm in J shell, all I need to do is just say parking lot A, and it shows me that in the first spot, spot 0, we have a Ford. Spot 1, we have a Toyota. All the other ones are empty. Let me see. Let me put a car, I will put a BMW inside spot 63. Well, and again, if I do just say, let me clear the screen. If I say parking lot A, show me what's in there. And there they are. And you can see there's BMW way over here. Everything else is empty. And again, arrays are going to be a fixed size, very similar to the metaphor of the parking lot. It's a fixed size. There's 100 spaces in there. Right now, only 3 spaces are being taken, or 3 elements are being taken. Now, if you're familiar with other programming languages, for example, Python is very popular, especially in the programming logic classes. If you're familiar with that, oftentimes we ask for the length of a list. Well, the length of a list is different than the length of an array. A list is a completely different entity. So a length of a list will provide the number of elements that are currently being used inside that list. The length of an array gives you that fixed amount. So if I just do parking lot A length, right? Now, it's not a method. Parking lot is not an object, so it's not a method. Length is basically a variable of an array. So this is saying, pull the variable array, tell me how many spots are in that array. 100. No matter what I do, I can fill this lot, I can empty this lot, I can do whatever I want, I can half full. I'm always going to get a fixed length of 100 for this particular lot. So let's review from previous content. If I need to iterate through an array, if I need to go through an array, would I use a definite loop or an indefinite loop? A definite loop says it's fairly easy to calculate the number of iterations, and we would use a for loop. An indefinite array say we're not quite sure potentially what the number of iterations. Well, with an array, it's a definite loop. With an array, we know the maximum size of this parking lot. Now, there may only be 3 cars in this parking lot, but we know that this parking lot, maximum number of iterations for this parking lot is going to be 100. Let's do some more examples. All right. String. Gonna be, how about we do classroom desk, all right? Or classroom A, separate classroom A, desk, and that's gonna be equal to, we're gonna say new, create a new array, instantiate a new array. It's gonna be a string, and this one, 25 students, or 25, not 25 students, but 25 desks. So it built me that array of 25 desks. Let's say at desk 1 or classroom A desk 0, it's going to be, who is it? Alice. And at classroom A desk, what do we say, 24, that's going to be Bob. Oh, I misspelled. Let's try it again. There's Bob. And now if I do classroom A desk, you can see that Alice is at the first one, Bob's at the second one. The desk in between, the 23 desks in between, they're empty. All right. How about one more quick one? We will say classrooms in a building, right? So we're going to say string, and we're going to say a building, classrooms. and we're going to instantiate it or create it new. It's going to be a string. And then we're going to say, how many rooms in class? We'll say 15 rooms in that particular building. And lo and behold, we create another array with a fixed amount of 15 rooms, right? And I would identify each room based upon the indice. I've used a bunch of strings here. I left the arrays empty. Let's begin to fill some of these arrays. And in another video, I'm going to do one of the examples, and we're going to be concerned with classes of students, not classes like classrooms, but classes of students where we have freshmen, sophomores, juniors, seniors, etc. So I want to create an array that has obviously a fixed amount, but a predetermined values inside those spots. So I'm going to create my array. I'll start with a clear screen here. And I'm going to start my array, and I'm going to say string. Now, I'm using string for a reason, not just so I have string information. It should look familiar to you from day one. There's something about that string with the square brackets that should begin to look familiar with you, and you should be thinking about, right? Not going to divulge that yet. So I'm going to say string, and in this one, I'm going to say class name, and I'm going to instantiate it with a new, and I'm going to say string. And this time, I'm not going to put the physical size within those brackets. But what I'm going to do is I'm going to populate that array with freshman, sophomore, junior, senior. Close this off. And you can see that I now have an array called class name, where the individual names are now part of that array. I can't expand it. It's not stuck, but it's fixed at 4 elements inside that given array. Can I go through that array? Can I iterate through that array? Absolutely. If I say, remember, we can predetermine the maximum number of iterations fairly easy. So that's telling me it's a definite loop. I'm going to say for, and I'm just going to say int I equal to 0, indices start at 0. And as long as I is less than 4, so it'll be 0, 1, 2, 3, so it's going to go through 4 times. It's never going to go to that 4th one. Keep incrementing I through the iteration. And here, I'm going to say system out print line class name bracket I. So let's look at this. We're iterating through an array, which is fixed size. We know it's 4. Later on, if we don't know specifically the array size, we can use length. You know what? Let's use array length. Next time we'll do array length. We iterate that number of times, and each time we print out the name. And I'll close up my braces, and let's run this. And you can see that it iterated through that. Let's do this one more time and clear my screen, but this time I will use a length. I don't like hard coding. Most programmers do not like hard coding. So I'm going to say for, and again, we're going to say create an integer that's going to be equal to 0. Indices start at 0. And keep iterating as long as now, what this is saying is instead of hard coding for, keep iterating as long as I is less than the length of the array. The length of the array is fixed at 4. So we're going to go through 4 iterations. And we're going to do the exact same thing. We're going to say system out print line. And we're going to say class name. Do the indice. And we'll close off our braces. And there we go. So as you're programming, try to avoid the fixed amount. Try to use length whenever possible. I knew there were 4 elements in there, but later on, if the array is something that we can't count immediately, for example, when I had 100 parking spaces, I knew there was 100 parking spaces in there, but if I physically had to look at it, just like if I was on Google Earth looking down at a parking spot, I would have to count there. Wouldn't it be just better if I use this length here? All right, let's do class year. Let's do another. Let's keep on this classroom type situation. I've been using strings. It's time to use integers. So I'm going to say int, and there's my square braces, and I'm going to say class year, meaning for 1 for freshmen, 2 for sophomore, 3 for juniors, 4 for seniors. So class year, and that's going to be equal to new. We're going to instantiate a new string, and we're going to say, we're not going to assign it 4, but what we're going to do is we're going to basically pre-populate and it built my integer array now with 4 integers. Now, if you're familiar with Python list can basically be any type of variable you want. Not the case with an array. You have string arrays, integer arrays, double arrays, any of the primary arrays. You cannot mix and match. You can't have doubles inside an integer array or anything like that. So it's how Java deals with stuff inside memory. So this becomes very efficient. They know, or Java knows, when things are being compiled, the class year array is going to hold nothing but integers. How about doubles? Let me paint a story here a little bit. The distribution of students is based upon a general percentage. So when they distribute, say there's 1,000 students that go to this particular high school, and they can have a rough estimate that like 30% of the students are freshmen, 27% of the students are sophomores, 23% of those students are juniors, and 20% of those students are seniors. So it kind of trails down. You often see that at high schools. The number of freshmen to the number of sophomores begin to trail down a little bit. Wouldn't that be a really great array where we put the distributions in there? Now, I'm using this example not just because I'm going to be expanding upon this example in another video, but each one of these is a 4-element array. The class name, the class year. Now we're doing a class percentage. So we're going to say, we're going to clear my screen first. And this one, we're going to say double. You see the pattern here? Primitive variable. We're going to do a primitive array. And we're going to call this class percentage. And it's going to be new. We're instantiating it. It's going to be a double. Again, I'm not going to assign it 4, but what I'm going to do is put those double values in there. All right. Semicolon. And guess what I just did? I just created an array with a bunch of doubles. Can I build an array in the program? Absolutely. Kind of like the parking lot. We started with an empty array and we, force fed it parking lot information. Can I build an array based upon all these other arrays? Absolutely. Now think about what I did. We have several arrays. We basically have a name array that has, freshman, sophomore, junior, senior. We have the year array, 1, 2, 3, 4, which is integer. We have a percentage, distribution percentage or class percentage there, which is doubles. I want to have an actual number of students array, a class distribution array. So I'm going to clean this up. I'm going to clean this up, and I'm going to keep this as an integer for a reason, but I'm going to say an integer, and I'm going to call this array class distribution, right? And I'm going to instantiate it with a new, and I'm just going to say it's an int, and it has 4. So it has 4 spots in it. Hit enter. And you can see that it filled it with zeros across the board. Strings we did null, integers we did 0. So now I'm dealing with several different arrays, all of the same length. So now if I use any of those arrays, I could iterate really one iteration 4 times, one for loop, but iterate 4 times. So let's do that. Sorry for the big jump. I made a whole bunch of typos there. So what do we have here? We have several arrays. Some are filled. One is not filled with any information. For example, the class name, the class year, the percentage, class percentage, those have been filled. The actual class sizes has not been filled, our class distribution. Why don't we print the array, let's create an array of that class distribution. So I've already created that array. I'll do it again just so we see it again because I had a big giant cut there. We'll call it class distribution. And we're going to instantiate it with new, and it's going to be an array of 4, right? We're not building it here at the string. We're going to run through an iteration and build it. And so we now have it. We had it before, but I just want to make sure. And I'm going to create an integer called class size. And we're going to assign it with 100. Okay? Now, let's look at the class distribution, or percentages. I'm sorry, let's look at class percentages. Class percentages, it's an array of 4, 0.3, 0.27, 0.23, 0.20, or 2. I want to create the class distribution based upon these values here. Well, let's use our for loop here. We're going to say for, we're going to create an integer I. We're going to make that equal to 0. Indices start at 0. And we're going to say as long as I is less than, I could put 4 here, but I don't like to hard code. So here I'm going to say class percentage dot length. It's not a method. It is part of a variable that's associated with that array. So I don't have those open and closed parens. And then we're going to increment I through each iteration. Let's get my braces. And here I'm going to just say, we'll keep it simple. We're going to say, class distribution I. So this array up here, class distribution, right, which is currently empty, I. That's going to be equal to class size, which is right now 100, times the distribution. And what's our class percentage here? Class percentage I. Seems pretty cool to me. Let's run this. Let's close it off with the brace. Something strange happened. And it's telling me what strange happened here. It's telling me that incompatible thing. You're taking class size, which is a integer. You're multiplying it by a double, and then you're trying to put it into a class distribution array, and this array is also an integer. Got to bring back our knowledge from previous classes. We need to typecast this. So let me speed this up a little bit. I equals 0. We've been through this. I less than class percentage dot length. Don't want to hard code. Plus I. And there's my first brace. And I'm going to say class distribution I is going to equal class size, which is a integer. So I forgot, I have to typecast. And now I say class size star class percentage I. Make sure we're all lining up here. So let's break this down while I was typing. We know what that for is going to do. It's a definite loop. It's going to go through the length of the array, and it happens to be 4. But then I have this class distribution, which is an integer array. That's up here, right? So we have to typecast it. We have to make sure that the content that we're putting into it is also an integer, or we get into this madness here. Then we're going to do the calculation. And the calculation is basically says class size, which is 100, multiply that by class percentage, what's at 0. So as this goes through, if I is 0, it's going to take this value here, 0.3, multiply that by 100, put it into class distribution 0. Anyway. And let me close my brace. Looks like it did something. Let's go to class distribution and let's see what that looks like. And there it breaks it up. So 0.3% is 30, 27, 23, 20. I've gone through a lot of these little examples. We started off by just examining just different types of arrays. Key elements are once you build an array, it's built, right? You're not going to be able to expand it. And you're not going to be able to sync it. There is a fixed amount of elements in that array, but we can address all those using indices. Then I basically took, I said, I'm going to create a series of arrays that they work with each other, right? They interact with each other. Each one of them are going to be 4. I can then iterate through those, and I keep beating this horse dead, that because we can predetermine generally easy to determine the length of an array. We just say, what's the length of the array? That's how many iterations we're going to go through. Because we can do that, that's a definite loop. We will often see a lot of for statements when it concerns iterating through an array. And then finally, I used an array and different values, and I created an array. So not on the fly, but within the code. Lots of examples. What are some other examples we can use for arrays? How about pages in a book? That's a good one. Post office boxes, houses in a development, lots in a development, students in a classroom, desk in a classroom, buildings on campus. You can see where all of this is going. If it's lots in a development, right? There's 10 lots in that development. That's a 10 element array. And even if a house is built there or not built there, how many houses are, you understand where this is all going. So pages in a book. What a great example. Pages in a book. I want to go to page 192, right? We've been using arrays our entire life. Books on a shelf. Right? Each shelf can hold X number of books. Then we have multi-dimensional arrays, which we will talk about later. So this was a good start of just understanding the basics of arrays. Okay. Hopefully I provided a lot of examples there. I think when we get into this type of area, especially with data structures and something like that, it's best if we just throw a lot of examples so people can really concentrate on the examples and potential use, the application, versus, the mechanics and things like that. So in other videos, we'll actually apply the knowledge that we gain from this video. But for this video, a lot of examples so we can understand it. That being said, hey, let's go on and learn something.